Hello everyone, welcome to my channel. I think we have three circuits here. This one, push button, resistor, LED and transistor. The other one, push button, resistor, LED and transistor behind. This one is push button, LED, PCB header, some resistors. This one is 12 volt supply. This is 5 volt supply. And this is 5 volt supply. This is a transistor buffer gate. So when you push the button here, LED turns on. Push the button here, LED turns on. Push the button here, LED turns on. But it seems that we have a problem here and also here. The LED is lighting. Unlike here, there is no light here. These two I think is defective because we are building a transistor buffer gate here using push button. So let us diagnose the problem by looking at the circuit diagram of each circuit. Let us see the circuit. The circuit of this one is this: transistor logic gates buffer, and this is the circuit diagram. This is my old project. So we have 12 volt supply here and a resistor, push button, transistor, resistor, LED. I'm using 222A transistor here. It seems the LED is turning on. It should not be because that is we are building transistor buffer gate here. What seems to be the problem here with this circuit? I think the problem here is there's no bias resistor here, and also there's no pull down resistor here, resulting into a leakage current because transistor has a breakdown voltage, and also the switch is hanging here. We need a pull down resistor here. So I designed this second circuit here, but still let us see the circuit here. The circuit of this one is this transistor switch 2.0 modified. So I modified this one with this one using the same transistor but different power supply here. We have a resistor on the collector, resistor on the emitter side, and the base. Just like here, we have resistor on the collector side, on the base, but we don't have a bias resistor here, or the resistor at the emitter side. So I build this resistor here. I put a resistor here, and that is the circuit. This is our layout. This is an old layout of this one. The layout of this one is this. It seems that still there's a problem, even we having this bias resistor here. So this is our new circuit, and let us see the circuit of this new circuit. We call this transistor switch buffer gate. So this one is the modification of these two old circuit. It has no resistor here, also here. No resistor here, but there's a resistor here. And it seems it is stable. See? We are trying to build a transistor buffer gate here. So, the symbol of buffer gate is this, an arrow, in, out. And the truth table is no input, no output. With input, with output. Pushing the switch here, and there's no leakage currents here and reverse voltage happening. So the circuit is stable here. I calculated all the values of the resistor. RD, RE, R1, RB. So let us calculate the resistor values here. Finding RIB, we have HFE formula. HFE is equal to beta is equal to IC over IB. IB now is equal to IC over beta 0.02 ampere divided by 100. 100 today is the HFE beta of this 222A transistor. And the collector current is the same as the current in the diode. And it's also the same as the current in the resistor RD. And it is given data sheet. The diode current rating is 0.02 ampere. And we got base current of 0.002 ampere. Using transistor formula here, we got IE is equal to IC plus IB. We know IC, that is 0.02. Collector current is the same as the diode current or resistor current here, which is 0.02 ampere, given data sheet of the LED. Plus our IB here, 0.02. IB is now 0.2 ampere. Finding R1. So KVL at R1 here, tracing the line, the green one, KVL is voltage supply minus the voltage drop here, BR1 is equal to 0. So the voltage across R1 is 5 volts, the same as here. Supply voltage is equal to the voltage drop across the R1 here. And then we have now find RD. So RD here, by using Kirchhoff's voltage loop, going to use this orange line, voltage supply here minus voltage drop across the resistor, diode, transistor, and the resistor at the emitter side. Also in this transistor, resistor, diode, transistor, emitter. So I'll supply here, voltage drop, collector emitter saturation is given data sheet, and that is 0.3 volts. And then we have here the BRD plus BRE is 2.7 volts. The voltage drop across these two resistors is 2.7 volts. Using voltage divide, I just divided by 2. And now we get 1.35 volts each, since they are equal. I just divided the two voltage here. So the sum of all the voltages here is equal to 5 volts. Voltage drop here plus diode, transistor, resistor is 5 volts. Now calculating the value of the RD using Ohm's law, we know the value of the voltage here and the current. Flowing the collector current is the same as the current in the diode, and that is 67.5 by using 100 ohms available resistor here. So we have a 100 ohm resistor here, Ohm's law again, calculating the value of RE. RE is, we know that this voltage is 1.35, and that we have current IE here, we know already here, and we've got 100 ohms. Calculating for the RB, base resistance here. By using Kirchhoff's voltage loop, we're going to follow this pink line over here, flows here to the base resistance, to the transistor, and to the resistor here. voltage supply minus voltage drops at the resistor here, transistor, and then this emitter resistor. We got here, and the base to emitter saturation voltage is 0.6 volts given in the data sheet of the transistor. We got the voltage supply of 3.05 volts, and using Ohm's law, we now know all the values here. The voltage drop across RB, now it is 15 to 50. I use 15 kilo ohms. Now here, finding R1, we know that IE is equal to IR1. This one is equal to IE. The current here is equal to the current here. See? And now we got here voltage at R1 is equal to the current R1 is the same as the current in the emitter, and that is 247.53. I use 270 available resistor here. Now we have here the pinout of the 222A EBC. This is the truth table, this is the symbol, and these are the parts using 100 ohms, 270 PS, breadboard, LED. Now our circuit is stable. With an input of 0, the output is 0. Input of 1, output is 1. LED turns on. So this is some sort of defective circuit. Okay, that is our 3 circuits. This one is the best circuit here. And thank you for watching the video. Bye bye.